So this unit is all about solving systems of equations. In class, we talked about solving using graphing. We talked about checking to see if a solution is indeed an answer. So today we're going to see about solving systems using elimination. The big idea in elimination is that you are going to add two linear equations together so that one of their variables cancels itself out. So when we add it, we're going to look for two variables that have opposite coefficients. Just a reminder, when you're solving systems of equations, every single answer is going to be an ordered pair. So anytime you answer a question, you need to write it as an x, y ordered pair answer. There's two examples that we're going to go through. This first one asks you to find the point where the two lines intersect. It's just another way of asking, solve the system of equation. So when I go through this, I'm going to look. I have 2x plus y equals 9 and 3x minus y equals 16. So I need to see if either of these variables will cancel itself out when I add this together. I have 2x and 3x, which that would give me 5x, so that won't cancel out. But I have a positive y and a negative y. A positive 1 and a negative 1 are exact opposites of each other, which means that these two terms here, when added together, will cancel itself out. So once I identify a variable that will cancel itself out, I'm going to add the problems together. So 2x plus 3x is 5x. Like we've already discussed, positive y plus negative y will cancel out to 0, which means I just need to bring down this equal sign and then 9 plus 16, which is 25. From here, as you can tell, I have a simple one-step equation. To solve for x, I need to divide by 5 to get x by itself, and I'm left with x equals 5. Now remember, I said that every single equation or every single solution for a system is going to have an x value and a y value. So I'm going to take this value of 5 and I'm going to plug it into one of my top two equations in place of x. It doesn't matter which one you choose, you should get the same answer once it's all said and done. So I'm going to take x equals 5 and I'm going to plug it into this top equation here. So I have 2. In place of x, I'm going to write what x equals, add y to it, and set that equal to 9. From here, I just need to keep simplifying this problem and solving the problem until I have y by itself. So I have 10 plus y equals 9. Subtract 10 from both sides. And I'm left with y equals negative 1. So I have an x value, I have a y value, and I'm going to write my answer as the ordered pair, 5, negative 1. Example 2, it's asking me to do the exact same thing. I'm going to solve the system of linear equations using elimination. Again, it's just another set of directions that mean the exact same thing. So this time again, I'm going to look through and see if either of my variables will cancel itself out as written. Positive x and positive x will give me a positive 2x, so that won't cancel. A negative 2y and a positive 3y, that would give me 1y. So again, that doesn't completely cancel out to a coefficient of 0. So I need to figure out which of my two variables would it be easiest to change to get it to cancel. I notice here, both of my x values have a coefficient of 1. So to get them to cancel, I just need one of them to be negative. So to do that, I'm going to multiply in a negative 1 to this entire top problem. What that does is if I'm going to change one part of my equation, I have to change every single piece so that it actually stays the same. So when I multiply negative 1 to that top problem, I'm going to be left with negative 1x plus 2y equals negative 9. Now when I look, a positive 1x and negative 1x will cancel itself out. so I can add these two equations together. 1x plus negative 1x will go away. 3y plus 2y is 5y. And 14 minus 9 is 5. Again, I'm left with a simple one-step equation. Divide by 5 on both sides, and we're left with y equals 1. I have my y value, now I need to solve for my x value. Again, you can choose any equation you'd like. I'm just going to go up to the top because I feel like it. So I'm going to start with x minus 2. In place of y, I know that it equals 1, so I'm going to write that and set it equal to 9. So this will be x minus 2 equals 9. So if I add 2 to both sides, I end up with x equals 11. So I take my x value, take my y value, and write my solution as an ordered pair. So those are two examples that I am showing you together. In class, we will get to more examples that are a little more in depth than this, but I just wanted to start off with some pretty simple ones. For the try your own problems, this first problem, I want you to solve it completely down to where you have an ordered pair. So look at the equation, identify if any of your variables would cancel as written. Once they are, add them together and solve. For this second problem down here, I just want you to get this problem started. If you realize this is a little different than any of the examples I've shown you so far. None of these variables are really even close to canceling each other out. So I just want you to try and come up with the first step of what would I do to get either x's or the y's to cancel each other out once I add them together. So try these problems on your own, bring them to class, and then we'll spend the whole class time working on elimination.